Hello everybody! Welcome to my fourth video over SAT Math Review. Today, we will be looking at another core skill for algebra problems, solving and interpreting systems of linear equations in two variables. Alright, so for our first question, we have to interpret a word problem and from that create a system of two equations. Alright. So it states that Hero and Sophia purchased shirts and pants from a store. The price of each shirt purchased was the same, and the price of each pair of pants purchased was the same. Hero purchased 4 shirts and 2 pairs of pants for $86, and Sophia purchased 3 shirts and 5 pairs of pants for $166. Which of the following systems of linear equations represents the situation if X is the price in dollars of each shirt and Y is the price in dollars of each pair of pants? Okay, so if X and Y both represent the price of their relative items, that means that their coefficients must be equal to the number of those items being bought by each person. So let's start off with an equation for Hero. So we know that he purchased 4 shirts, so 4 times the price of shirts in dollars, which is X, plus 2 pairs of pants, so plus 2, times the price of pants in dollars, which is Y. And we know that equals $86. Similarly, Sophia purchased 3 shirts, so 3 times X, and 5 pairs of pants. And we know that equaled $166. And so, if we look at our answer choices, we can see that A matches with what we have written down, so that is our answer. Okay, so in this problem, we are provided with a graph of 2 lines. And given these 2 lines, we have to find the solution in X and Y. Okay, so if you have 2 equations, let's call them f of x and g of x. The point at which you'll be able to solve for them is when they are equal to each other. Now, the way that this is represented graphically is that both of these lines will cross each other. So the point at which the 2 lines cross each other is the point at which the 2 equations are equal. So, looking back at our graph, we can identify the point at which they cross from each other. So it is 3 on the x, and it is 4 on the y. So that tells us what the solution to the system is, which is answer choice B. Now, in this problem, we're actually given a system of equations, and we have to solve for one of the variables, that being x. So, we're told that 1/2 y is equal to 4, and that x minus 1/2 y equals 2. Okay, so because we know 1/2 y is equivalent to 4, we can actually substitute that for the 1/2 y in the second equation. So what we can do here is x minus 4 equals 2. Now, if we add 4 to both sides, we get x is equal to 6. And that will give us answer choice D. Okay, so this problem is a bit more complex than what we've previously seen, as it is both a word problem that we have to create a system of equations for, and then we have to then solve for one of the variables in that system of equations. But it's certainly nothing impossible. So, the problem states that a group of 202 people went on a camping trip, taking 60 tents with them. Some of the tents held 2 people each, and the rest held 4 people each. Assuming all tents were filled to capacity and every person got to sleep in a tent, exactly how many of the tents were two-person tents? Okay, so before we create our system, we first have to establish our variables. So I'm just going to say that x is equal to the number of two-person tents, and that y is equal to the number of four-person tents. Now we can start to establish our equations. So we know that there are 202 people in total. And so there are 2 people in every two-person tent, so 2x. And then the rest of the people, there are 4 in every four-person tent, so 2x plus 4y. Now, we also know that there are 60 tents in total, and that they must be equal to the number of both tents added to each other. So 60 equals x plus y. Now, in the second equation, I am going to solve for y by subtracting x from both sides. So we get y equals negative x plus 60. Now, I am going to substitute that in to our first equation. So we'll get 202 equals 2x plus 4 times negative x plus 60. Multiplying that out, we get 202 equals 2x minus 4x plus 240. Now, adding our x's together and subtracting 240 from both sides, we get negative 2x equals negative 38. And if we then divide by negative 2, we get x equals 19, which is answer choice C. So this problem is a bit similar to something we've already seen. It's just stated in a slightly different way. So we are given a graph of 2 linear equations, and we are being asked which of the following systems of equations has the same solution as this graph. Okay, so as we have previously established, when you are given 2 equations, the point at which the system of equation can be solved is when both lines are equal to each other. So that's when f of x is equal to g of x, which is when both of the lines are crossing. So when we're looking at this graph, we can identify the point at which they cross. And if you'll notice, the x value is about 1.5, I'd say, so 3/2. And the y value, because it's on the x-axis, is 0. Now, the way that they wrote the answers out isn't in this point form, but it's basically saying the same information. So we can also translate this to x equals 3/2 and y equals 0, which, when looking at our answer choices, is choice A. Now, in this problem, we're faced with a bit of a more challenging system of equations. So we are given 2 systems of equations wherein there are 2 unknown constants. So it states that ax plus by equals 72, and 6x plus 2by is equal to 56. and that a and b are both constants, and that the graphs intersect at the point 4, comma, y. And so then it is asking us, what is the value of a? So it's not looking for x or y, it's looking for the value of the constant a. So the way that I would first approach this is plugging in our point to both equations. So when x is 4, so that's 4a plus y is the same, so it's still by. That is equal to 72. And 6 times 4 is 24, plus y is the same, so 2by equals 56. Now, looking at this, what I'm going to try and do first is solve for b, so that I can then plug that in to our first equation and solve for a. So what I'm going to first do, looking at our second equation, is subtract 24 from both sides. So that will give us 2by equals 32. Now, to find and isolate b, what I will do is divide by 2y. So 32 divided by 2y is b at this point. So what I will then do is put that in for b in my first equation. So 4a plus 32 over 2y times y equals 72. And so what you'll notice is that because y is in the denominator, it will actually cancel out with the y it's being multiplied by. So that takes that out of the equation. So we're left with 4a plus 32 over 2 equals 72. And we know that 32 divided by 2 is 16, so 4a plus 16 equals 72. Subtract 16 from both sides. That will give us 4a equals 56. And finally, we will divide by 4, giving us a is equal to 14, which is answer choice D. Okay, so just looking at this, it seems like a pretty standard system of equations problem. Except instead of asking us to solve for a certain variable, it is asking how many solutions there are to the given system. So, just looking at the system, we are told that negative 12x plus 14y is equal to 36, and that negative 6x plus 7y is equal to negative 18. Now, just by looking at this, it looks to me like elimination would probably be the best method to solve for this. But something that you might notice initially that is odd is if you multiply the second equation by 2 and then subtract the second equation from the first one, both the x's and the y's will cancel out, which seems a bit odd, but let's just see what happens. So we'll multiply the second one by 2, so that'll give us negative 12x plus 14y equals negative 18. And now we'll subtract the second equation from the first one. So negative 12 minus negative 12 is 0, x. And then 14 minus 14 is also 0. So 0 on the left side. And then we'll take 36 minus negative 18, which is equivalent to 36 plus 18. And that will give us 54. Now, that is a bit of an odd statement. 0 equals 54. The last time I checked, that is not true. So, When you get a solution that is inherently illogical, it doesn't make sense, it is setting two unequal items equal to each other, that is how you know that the system of equation has no solution. So, for this one, there are 0 solutions, and our answer is D. Okay, so for our final question, we have a bit of a challenging word problem, but it's nothing impossible. So, it states that a sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. The sample was created by combining two pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. What was the mass in grams of the silicon in the second piece? Okay, so before we solve this, first I would like to define our variables. So I would define x as the total mass in grams of the first piece. And similarly, I would define y as the total mass, sorry for my handwriting, of the second piece. Okay, so now that we've got that established, we can start to define our overall equations. So we know that the alloy itself, the finished product, is 50 grams. So that must be equivalent to the added up masses of the first and second alloys used to create it. So we can get the equation 50 equals x plus y. Now, we also know that the product, which is 50 grams, is 50% silicon by mass. And 50% of 50, so 0.5 times 50, is 25. So there are 25 grams of silicon in the finished alloy. So we can take 25 and set it equal to the total mass of x multiplied by its percentage of silicon by mass. So we get 0.3x plus the mass of the second piece multiplied by its percent silicon by mass. So that equals plus 0.8y. Now, we're trying to find the mass in grams of the silicon in the second piece. So I am going to start off by finding what x is, so we can then plug it into the second equation and solve for y. So x equals negative y plus 50. Plugging that in, we get 25 equals 0.3 times negative y plus 50 plus 0.8y. Now we can multiply that out, and we get 25 is equal to negative 0.3y plus, what would that be? 15. Yes, 15 plus 0.8y. Now, we subtract 15 from both sides and we add the two y values together. We get 10 is equal to 0.5y. Now, dividing by 0.5, we get y is equal to 20. Now, you might be thinking that we're done, but no. Remember, y is the total mass of the second piece, and we are looking for the mass in grams of just the silicon in the second piece. Now, we know that the second piece was 80% silicon by mass, so we will take our answer and multiply it by 0.8. So 0.8 times 20 is equal to 16. And that will give us our answer, being choice B. Thank you so much for watching, and I wish you the best of luck reviewing for your SATs.